Lesson 5-4a, the remainder theorem. Polynomial division can be used to find the value of a function. From the division algorithm, we know that f of x divided by g of x equals q of x plus r of x divided by g of x. So q of x just means that's the quotient, the answer to a division problem, and then r of x just means the remainder divided by g of x, which is the divisor. That's just the way we write our answers. And that f of x equaling q of x, so the quotient times your g of x, which is your divisor, plus your remainder, r of x, where q and r are unique and the degrees of r is less than the degree of g. That's how you get back to your original function. So suppose we were to call the dividend p of x and the divisor x minus a, then the division algorithm would be p of x divided by x minus a equals q of x plus r divided by x minus a. And p of x equaling qx times x minus a plus r, where a is a constant and r is a remainder. Since any polynomial can be written in this form, evaluate p of x at a gives the following. So in other words, to make this a little bit simple, let me put some numbers in there. So if I said 9 divided by 12 divided by 3. If that's what the function is, that would give us a quotient of 4 plus the remainder of 0 all over 3. That's really what they're saying here. Or if I said 12 divided by 5, 12 goes into 5 2 times, so our quotient would be 2 plus a remainder of 2. And this would be 2 over 5. So 2 plus 2/5 would give us our answer. So here you can see it broken down a little bit further. P of x equaling q of x times x minus a equaling r. You're using polynomial function, p of x. When you substitute a for x, because remember this has to equal 0 in here, so that would be 0. So q of a times 0 equals r. So P of A equals R. So the remainder theorem just says that if you're given a value, plug that into the function, and that will tell you what your remainder would be at the end. So for a polynomial P of x and a number A, the remainder upon division by x minus A is P of A. So an example using synthetic division, if they're saying x is 5, if you put 5 in for x and simplify it, it will tell you what your remainder would be. So you can either do direct substitution or synthetic division. So the synthetic division, bring the 1 down, 5 times 1 is 5, add straight down, you get 1, 1 times 5 is 5, 7 plus 5 is 12. Or you can do it, just put the 5 in here, and you'll get your remainder. Now applying the remainder theorem to evaluate the function is called synthetic substitution. You may find that synthetic substitution is a more convenient way to evaluate a polynomial function, especially when the degree of the function is greater than 2. So you don't have to put that number in so many times. And remember, what power do you have to raise it to? So synthetic division might be an easier form for doing that, or synthetic substitution. So our first example, use synthetic substitution to find f of -3 if f of x equaling -2x to the 4th plus 3x squared minus 15x plus 9. So I'm going to put -3 in here. We're going to use synthetic substitution. So this would be -2. I don't have any x cubed, so I'm going to put a 0 there. 3, -15, and then 9. Bring down the first number. So put a -2 here. Multiply, and we get 6. Add straight down, you get 6. Multiply, you get 18, -18. Add, we get -15. -15 times 3 is 45. Add, you get 30. -3 times 30 gives us -90, which will give us a remainder of -81. Next, use synthetic substitution to find f of 5. So we have 5 here. We got 3, -3, -20, and 4. Bring down the first number, multiply, we get 15, add, we get 12. 12 times 5 is 60, add, we get 40. 5 times 40 is 200. Add straight down, you get 204. Next, use synthetic substitution to evaluate this. So if I put 8 in there, we got -6, we have 52, we have -27 and -31. So we have -48. Add straight down, we get 4, gives us 32. Add straight down, it gives us 5. 5 times 8 is 40. Add, and we get +9. So 9 would be our remainder. And example 2, apply the remainder theorem with a word problem. It says the total production of eggs in billions in the United States can be modeled by the function f of x equaling 0.007 x cubed minus 0.149 x squared plus 1.534 x plus 84.755, where x is the number of years since 2000. Predict the total production of eggs in 2025. So that's 25 years after 2000. So if I use synthetic division, that would be 25 here. And I would have 0.007, negative 0.149, and 1.534, and 84.755. Bring down the first number, 0.007. And we multiply, so 25 times 0.007 gives us 0.175. If I subtract 0.149 from that, gives me 0.026. Multiply that by 25, we get 0.65. Add 1.534 to that, gives us 2.184. Multiply that by 25, and we get 54.6. So add that to 84.755, and we get 139.355. So this would represent billion of eggs. And our last question. The number of 3D movie screens in theaters worldwide has been increasing. The growth in number of these screens can be modeled by the function f of x equaling 25x to the fourth minus 702x cubed plus 7,114x squared minus 19,437x plus 14,287, where x is the number of years since 2005. Determine the number of 3D movie screens worldwide in 2018. So 2018 is 13 years after 2005. So this would be 25 negative, just be 0, and then negative 700. Actually, no, this would be negative 702, 7114, 19,437, and 14,287. Bring down the first number. 25 times 13 gives us 325. Do the math, 702 gives us a negative 377 times 13 gives us negative 4,901 plus 7114 gives us 2,213 times 13 gives us 28,769 plus 19,437 gives us 48,206 times 13 gives us 62,678. And if I add 14,287, we get 640,9 965. So that would give us a total of 640,965. But I made a mistake here. This should be a negative sign here. So if I did negative 19,437 plus 28,769, that gives us 93,32. Multiply that by 13, gives us 121,316. Then add that to 14,287, gives us 135,603. That would be the number of 3D movie screens worldwide. So that is our lesson on the remainder theorem.